Hello, this is Mrs. Huntley. This is Module 7, Lesson 2, Square Roots. You should be on page 4 of your module, and your essential question is how can I approximate the value of the square root of a non-perfect square more precisely? If you remember, in Lesson 1, we were using the Pythagorean theorem to help us find missing side lengths of right triangles. And when the side length was a non-perfect square, we were estimating it between two perfect squares to come up with, for example, if our missing side length was the square root of 73, we said, 73 was not a perfect square, but it'd be somewhere between the perfect square 64 and the perfect square 81. So the square root of 64 is 8, and the square root of 81 is 9. So the side length that we were looking for was somewhere between 8 and 9. In this lesson, we're going to learn how to get a little bit closer to the precise number. So let's take a look at our example here. We're looking for the diagonal of the square unit. This diagonal here coming across. And this is actually an S. That is not an 8. I thought it was an 8 at first, and I was like, I'm not understanding this problem. It's an S. So they're asking us to find the value of S. So we're going to use our Pythagorean theorem. We have two legs here. They're both 1 unit in length. So we'll say 1 squared plus 1 squared equals S squared. 1 times 1 is 1, plus 1 times 1 is 1 equals S squared. So 2 equals S squared. 2 is not a perfect square. If we look back at our square root table that we created, looking on this side, we're looking at our squares. Don't get confused because there's a 2 over here. That's your square root side. This is your square side, and there is no 2 here. It's going to be somewhere between 1 and 4. It's going to be greater than 1 and less than 4. So my value for that diagonal is going to be somewhere between 1 and 2. Now 2 is a lot closer to 1 than it is 4, so it's going to be that my answer is going to be closer to 1 than it is 2. This will make sense as we move on in the lesson. For this part of the lesson, what I want you to recognize is that 2, is not a perfect square. The value of the square root of 2 will be somewhere between the square root of 1 and the square root of 4, kind of reviewing what we did yesterday. What I'd like you to do right now is pause the video and using your chart that's on the inside cover, see if you can answer these 4 questions. The first one is determine the positive square root of 81. If it exists, explain. Determine the positive square root of 225. If it exists, explain. Determine the positive square root of negative 36 if it exists, and then explain yourself. And then finally determine this positive square root of 49 if it exists, and then explain yourself. So pause the video and then come back after you have worked these out and see if your answers match my answers. Alrighty. So the positive square root of 81, some of you have been memorizing and you know it's going to be 9 because 9 squared equals 81. That's how I would explain this. I know the square root of 81 is 9 because 9 times 9 equals 81. The positive square root of 225, positive square root of 225 is 15 because 15 times 15 or 15 squared equals 225. It's the square root undoes squaring. So like when we next lesson, I think it is, we're going to start seeing equations that have our exponents in it, squares and cubes. To undo a square, you're going to take the square root just like we do in the Pythagorean theorem. Okay, so the positive square root of negative 36, if it exists. In order to get a negative product, my factors must have one negative, one positive. Therefore, there can't be a positive square root of negative 36. Positive 36 could be the product of 6 times 6 or negative 6 times negative 6, but I could never find a square root of a negative 36. It doesn't exist. Last one is 49. The square root of 49 is 7 because 7 times 7 or 7 squared equals 49. So that's how I would answer those questions. Hopefully that was easy for you and you're like, okay, let's get a little bit more challenging. And let's. Page 9. So we're still going to work on estimating the more precise value of the square root of 2. And here we've got a number line. And this first problem, or this first discussion question, I guess I should say, it says place the numbers, the square root of 1, the square root of 4, the square root of 9, and the square root of 16 on the number line and explain how you know where to place them. So let's think about this. If I'm using this number line and I wanted to add these values on there, where would they fall? So the square root of 1, let's look back at my chart. The square root of 1 is 1. So I'm going to come here and write at 1, that's also the square root of 1. Square root of 4 is 2. Oh, I just almost wrote a 2 there. The square root of 9 is 3. And the square root of 16 is 4. How do I know? I know 2 times 2 is 4, so the square root of 4 is 2. And I can write that. And so, excuse me, and so on. So if I'm explaining all of these, I would write, I know 3 squared, or 3 times 3 is 9, so the square root of 9 is 3. Square rooting undoes it. Now it says place the numbers, the square root of 2 and the square root of 3 on the number line and be prepared to explain your reasoning. So let's look at this number line. We know how to count on a number line. We've been doing it for a long, long time. So if we're starting at 0 and then we have 1, 2, 3, wouldn't it be logical that my square roots would go up the same way? So the square root of 2 would come somewhere between the square root of 1 and the square root of 4. So I could place the square root of 2 here. And the square root of 3 would come next, because it's going to be logical. And they'd be somewhere like that on the number line. So I said, oh, the next one wants me to place 5, 6, 7, and 8 on the number line as well. So why don't you go ahead and see if you can do these next two without me. You can pause the video and then see if your answers match mine. Okay. Hopefully you did something similar to what I did on your number line, and I know mine is a little bit hard to read because my pen is a little bit fat. But let's take a look at this. So we're counting, and counting goes from 1 to 16 on our square roots, and it would be logical that they would go in order. Okay? So let's take a look at what this means. It means that all of these whole numbers here have square roots, but they are not perfect squares. And to determine more precisely, like the value of the square root of 2, let's look at this space between 1 and 2 a little bit more carefully. If I take the difference between the square root of 4, or I'm sorry, 4 and 1, if I take the difference between 4 and 1, 4 minus 1, that's 3. And if I look, there are 3 spaces on my number line between 1 and 2 that have these square roots on them. See, I'm starting here, and this would be 1, 2, and then 3. So the difference between 4 and 1 is 3. So we know that I should back up a little bit. We know that the square root of 2 is going to be greater than 1 and less than 2. So it's going to be 1 and some fraction or decimal. We have to figure out what fraction or decimal now. Now we know that there's 3 total spaces. The difference between 4 and 1, there's 3 total spaces between this 4 on the number line and this 1 on the number line. So that's going to be my denominator. Now we're looking for the square root of 2. And the difference between 2 and the square root of 1 is 1. So I'm going to estimate the value of the square root of 2 to be 1 and 1/3. That's how I can get more precise. So I'm taking the difference between the square roots that I'm looking at, and then I'm taking the difference between the number I'm looking at and the lower square root, and that's my numerator. The other one is my denominator. It's like a ratio, the whole, or the part to the whole. Let's look at another example real quick. And then, so let's turn to page 10. So it says determine the positive square root of the given number if the given number is not a perfect square. Determine which number the square root would be closest to. Then use guess and check to approximate your answer to 1 or 2 decimal places. Instead of doing that, we're going to do the fractions that I just taught you on the one before. So square root of 49, check your chart, and let's take a look at it. If you haven't memorized it yet, hopefully you're writing it down. So look in this column. Is there a 49 there? There is indeed. It's 7. So square root of 49, I'm going to write it in here because we need all of our workspace, is 7. If we have to say why, it's because 7 times 7 is 49. 62 is not a perfect square. Whoops, I guess I should have you check your square root chart. Look for 62. It's not a perfect square. It's less than the square root of 64, and it's greater than the square root of 49. Okay, 62 is not a perfect square. It's between the perfect square of 49 and the perfect square of 64. So if I'm looking at this, the difference between the two perfect squares, 64 minus 49, doing some subtraction here. I've got to borrow, so that's going to be a 5. This is going to be a 1. So the difference is 15. Then the difference between 62 and 49, the number I'm looking for, and the lower perfect square, again, I've got to do some borrowing. That's going to be 3. So that's going to be 13. This is my numerator. This is my denominator. So if I'm estimating the square root of 62, it's going to be 7, because the square root of 49 is 7. So it's going to be 7 and 13/15ths, about. Because again, we're still estimating. That's still not an exact number. So see if you can take a look at 122. Let's see if it's on our chart. Look in here. 122 is greater than 121, but less than 144. Why don't you go ahead and pause the video and see if you can figure out how to set up and figure out the fraction that would bring us a little bit closer. So we know it's going to be between 11 and 12. So it would be 11 and some fraction. So pause the video and see if you can work that out. Okay, so 122 is not a perfect square. It is between the perfect square of 121 and 144, obviously closer to 121. So I'm going to subtract 144. I'm going to subtract 121 from 144. The difference between these two is 23. The difference between the number I'm looking for and my lower number is 1. So I know I'm going to take the perfect square of the lower number, 121. So that's going to be about 11 and 1/23. Hopefully that makes a little bit of sense to you. Let's take a look back here at our number line. See, what's happening is when we were figuring out the 1 and 1/3, from 1 to 2, we've got 3 spaces in between. That space was cut up into thirds. So if I was looking for the square root of 3, I would say it's 1 and 2/3. If I'm looking for the square root of, say, 7 here, I know it's going to be greater than 2, less than 3. How many spaces on the number line are there here? Let's see, it's 1, 2, 3, 4, 5. So 5 is going to be my denominator. And then from here to 7, it's 1, 2, 3. So it'd be 2 and 3/5. We're just breaking up the number line into equal parts that are showing us how many square roots are between those perfect square numbers. If it doesn't make sense to you right now, it will while we're working with it. And during this unit, we're working on number sense, and that's why we're not using our calculators, because I know you punch it into your calculator, easy peasy lemon squeezy, it's going to give you an answer. Learning how to estimate like this will give you number sense so that you know when you're plugging in your calculator whether it's correct or not. Doing number 8 should be pretty easy. It is indeed a perfect square. You just have to figure out which one it is. And then answering the question for number 9, which of the numbers in exercises 5 through 8 are not perfect squares, explain. Again, I'm thinking that one's pretty easy. And if not, I'll tell you right now, 6 and 7 are the ones that we had to estimate, and we estimated them to a fraction. So in summary, there are numbers on the number line between whole numbers. These are fractions and decimals, and we can estimate what fraction or decimal the square root of a non-perfect square is closest to. And that's what we were working on here. There are many, many, many whole numbers that are not perfect squares. There are much few, I mean, there's infinitely many perfect squares because there's infinitely many numbers, but there's way more numbers that are not perfect squares. So that concludes this lesson. I hope you have an awesome evening and a great weekend, and I will see you on Monday. Bye.